tortoises and humans have very similar eyes in how they work and how they perceive the world, but eyes of different animals work quite differently. But from an evolutionary perspective, why have eyes evolved? Yep.
Because as people have gotten, like, maybe back 100 or 200 years ago, they might not have had the, like, stuff to...
We're talking about people, we're talking about eyes on this planet.
Because humans came from...
Not about humans. Why have eyes evolved?
Because... to suit them.
Okay, yeah, Rena?
Well, isn't it like the better you can see, the easier you can catch things like prey?
Yeah, that, like, you can get food more easily, yeah.
Change in the environment.
Changes in the environment. It does give you an advantage. We'll get you
Suit adaptations.
Yeah, it's an adaptation. It gives you an advantage. The first eyes really just allowed you, like bacteria, strangely enough, bacteria are too small for eyes, but some bacteria, that's a circular, a coccoid bacteria, they actually use their body like a simple lens, and they have receptors here, and they're able to detect bright and dark. And what they will do is they will swim towards bright areas, because where there's bright areas there's food, and where there's dark areas there isn't. So they use their entire body almost like a simple eye to try and track down bright areas where they'll be able to find food. It's good for avoiding predators, it's good for finding food. Key learning intentions, we have to understand that what we see are real images. When light waves enter your eyes, are transmitted to the retina at the back of each eye, and at the retina they are converted to electrical signals. So we take light signals and convert them to electrical. We need to know the structures of the eye: optic nerve, retina, rods and cones, lens, iris, cornea, pupil, blind spot. We need to be able to look at a diagram, label those, roughly work out what's going on. The rods and the cones are what are responsible for black-white vision, in the case of the rods, so your night vision, and cones are for colour. And they're not necessarily common in nature. Colour vision isn't not necessarily selected for. There's a few key points there. Now, we looked at lenses just before we started this. We talked about how we have convex converging lenses and concave diverging lenses, but we're most interested in convex lenses because they produce a real image, this one here, and that's basically how your eye works. If you were to take that and put that around it, that's your eye in its simplest, crudest form. That there's a lens in there and you project a real image onto the back of your eye, and then the nerve cells there are stimulated and they transmit that electrical signal to your brain. Now, a convex lens produces a small upside down real image whenever the object is further away from the lens than its focus, and so does your eye. So here is, in this case, the lens of your eye here, a flower in the real world, and the real image that you get is of a smaller version of that flower. That's the retina on the back of the eye. So it's literally being projected there like a movie projector. And the nerve cells here that are hit by light are stimulated and send electrical signals down that optic nerve there. Okay, we'll look at more of this. But the interesting thing is, that part there, does anyone know what that part of your eye is called?
The cornea.
No.
Retina. Iris.
Blind spot. You actually have in each eye a section, like if you close, everyone close one eye, cover it if you can't. Now, does anyone have a big black circle that you can't see anything?
Yes. No.
Probably not.
What?
But what I'm saying is, because there are no nerve cells here, that's optic nerve. So that's actually a blind spot where you have no vision at all, but your eye just fills in those details for you. It's like a bonus. And so the world you're seeing, you're looking around, you go, yeah, I'm seeing everything, but I can actually show you on a piece of paper. We have a look at one dot and the other dot just vanishes because it's sitting on it's the image of that dot is hitting the blind spot, and your brain can't get around that at that point, and so you just lose it. And so the eye itself is functionally a lens with nerves that will pick up the signals. So the cornea is that covering on the outside of the eye. Now, when we come back to this, anything with a dot on it, that is testable, that's examinable. Okay? The transparent covering, it lets light into the eye, so that's of course important. It bends light a little bit, that's important too. And it also just stops stuff from getting inside your eye. So it's like a goggle for your eye, if you like. It's just a fairly hard, and when you do the dissection, you can stab it with your scalpel and it'll crunch because it's got these layers on it. Yes?
Sorry, when you get something in your eye,
Mm-hmm.
and say like blink, where does it go?
The eye, it's just sitting on here.
And then like, because they tell you like blink 1,000 times. to
Yeah,
get
and
rid of it.
tear up and it'll wash off. Yeah, it'll organise itself like that. So it doesn't get in your eye so much as on that. And you've got a lot of nerve receptors there. So that's why if you get a poke in the eye, it hurts a lot. Because eyes are very important. And so this is one way to encourage you to protect your vision by making it really painful if something touches your eye. It's not like elbows. You're pretty much fine. Funny bone, different matter. If something goes hard in there, it could break the elbow. So that's why there's a lot of nerves there. So you bang it, that hurts. But the rest of your elbow, you're fine. You don't pick up things with your elbow. Fingertips are different. A lot of nerve endings. Eyes have a huge number of nerve endings. Now the pupil is that black circle in your eye. Now the pupil isn't a thing per se, it's that gap. And it adjusts, it's the adjustable opening in the eye that adjusts so that more or less light can come in. Now the iris is that coloured component of the eye. It adjusts the pupil size and controls light intensity striking the lens. So there's the coloured iris. This person has green eyes, if you like. And if it's bright outside, this gets small. The muscles, we'll talk about those. If it's very dark or you're in a cave for a long time, this will get really, really big. Lens focuses light through the vitreous humour onto the retina. This is the lens here, and this can be adjusted. So these muscles here will either stretch the lens so that you can perhaps see things further away, or it'll compact the lens, and then you've got better close-up vision. So, there's that adjustment process. As you get older, that becomes less adjustable, and so, girls at the back, you've got to pay attention. That becomes less adjustable, and so your vision starts to deteriorate with age, and that's why older people tend to wear glasses. So the ciliary muscles, circular muscles that relax or tighten and enable the lens to change shape, these ones here, the ciliary muscles. So they're important for that particular job. And there have been exam questions in the past where if you were infected with a bacteria that paralysed your ciliary muscles, what would the outcome be? And you'd go, well, I can't change my focal length of my eye. So however I'm seeing, I'm just going to stay like that until the bacteria is cleared out. So, if I can focus at a metre, anything closer is blurry, anything further away is blurry, and I'll just be locked in at that place. Now the vitreous humour, actually that should be blue, because we never ask vitreous humour. That's the jelly-like substance here, and you'll see that when we do the eye dissection as well. It's transparent, so that the light can go through. And it keeps the shape of your eye. So if you hear stories of people, if they get poked in the eye with a wire, you're supposed to leave the wire in there, because if you remove the wire, the vitreous humour drains out, the eye deflates, and then it's done. It's not really salvageable. But if you can manage it, so we do our first aid training, and if someone gets something in the eye on camp, we're supposed to put a donut bandage around here, so you roll a bandage and put it around there, and then you put another thing on there, and you have to bandage both eyes, because if this one moves, then the other one will follow as well. So you cover both so they can't see anything. Both eyes closed and they won't move their eyes, and then you've got to get them out. Yeah. Question?
Quickly, when we're doing the eye dissection, where's the eye coming from?
It's cow eye, I told you that. It comes from a butcher. So instead of them putting into sausages or something, they'll just give it to us, which is wonderful. Okay, and we are having, that reminds me, sausage sizzle tomorrow. Remember, eat up everyone. Eat up, lips and hooves. Delicious. Retina transforms the image into electrical impulses, and through the optic nerve they reach the brain. So this is all nerves back here on the back of the eye. And in the same way that those nerves, when I tap my hand, they can take impact, pressure, and they say, oh, something's touching your hand. And then I have nerves that detect heat. So when I'm going, oh, that's a hot sauce, but I won't touch that. You know, so your pain receptors work in the same kind of area. If the stimulus is great enough, you send a nerve signal. And for these ones here, they're very, very sensitive to light, the rods especially. And so if you get a little bit of light hitting them, they'll send a signal to your brain, and you interpret all of that as the images of the world out there. Okay, tapetum we don't do, but this is why animals' eyes are like cows and horses. You shine a torch out there and they seem to glow when that light hits them. And it's because of that reflective layer in the eyes. So it gives them slightly better night vision than we do. Yes?
Where is it?
It's in the eye itself. I actually would have to find a picture to show you where it is. I think it's relative to the retina. The fovea is a small depression in the retina where the cones are really concentrated. So there's your fovea there. So you've got a very high level of colour vision at that particular point. But again, we don't so much study the fovea. And then the optic nerve is very important. It carries the signals from the retina, and of course there's that blind spot. Because if you think of that like a movie screen, and there's the hole where information has to leave, and so you don't have receptors there to detect light signals, and so you're quite blind at that blind spot. It just gets filled in for you afterwards. Okay, now that's the same information, just a little bit more detailed. So not a bad slide to have a look at prior to an assessment, or for the prac write-up as well. But I covered most of it previously, so that's not too bad in terms of helping you with assessments. Now, the retina contains special cells called rods and cones, both of which sends the message to the brain. Now that's a bit naughty. I put special cells. I really should put special nerve cells, because that's what they are. And rods are very light sensitive. They respond only to light and dark and help us to detect shapes. So they're particularly useful at night. Now, the cones need more light to be activated, come in three types to detect colours: red, blue and green, and that's why you have colour vision. So, which is similar to the old TVs with their pixels, red, blue and green pixels, and you put them together at different intensities and you get different colours. Okay? The cones are towards the centre of your eye, and so at night time, if you go outside, it's very dark, you think you can hear an enormous creature coming for you, and you're going, oh, I can't see anything. Well, if you turn your eyes, if you're looking over there, turn your eyes over there, but pay attention out the corner of your eye, and more light will hit the rods, and you'll be able to see, hopefully the thing that's coming to devour you. But you can actually see out the corners of your eyes better at night than you can at the centre, because those cones respond better to colour vision, but they need more light photons to hit them before they will fire, whereas the rods are really, really sensitive. Okay. Any questions about that? Yes?
Why is it like that in art and everything to make all the colours they don't use red, blue and green?
Yeah, but they're absorbing, remember?
Okay.
So like, remember when you say, oh, we're using, look, when we say I have red paint, what you're saying is I have a substance and the atoms in it absorb all wavelengths of light except red. And so when you're combining paints, you're combining substances that have different absorbing abilities. And I think, now you got me thinking.
Good job, Rena.
Now I'm confused. Thanks, Rena. Because I'm thinking when you mix substances at the level of paint, whether you can change at the level of atoms, maybe the red paint, so that the light that bounces off changes, like if there's a molecular bonding or something like that would change things. See, now you've got to make it all complicated. You've broken my brain. Okay, colour blindness. We don't study because so you do in year 10. But some people lack, if you lack one of the cones, if you lack one of the cone types, then you'll be blind to that colour and to a range of colours probably. And so you won't be able to tell the difference between some colours, most notably red and green. Simple. There's number 82 here.
What?
If you have normal colour vision.
I can't see.
Yeah, that's me having a bit of a joke. That's an eye test, and if you were colourblind, that's perhaps how you would see it. So that's how it feels to be colourblind. So
I see 83. Yeah, I see 83.
there's nothing in there, so you're just kidding yourself. Now,
I see 730.
now here's the interesting thing. Some
I
people who are colourblind go through almost their whole lives without knowing they're colourblind, because normally at around about 18 they'll find out because you're doing a driving test, and I'll show you one of these. But you know, I see this as red because my parents taught me that this is red when I was a baby. And for someone who was colourblind, it might look almost from grey from my end, but they learn that shade is called red. So they just walk around saying red, 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 red. And then when they do the driving test and they do a test like this, they realise, oh wow, I'm actually colourblind to red. And it won't impact you, you can still drive and everything like that. You can't be a pilot though. So they just demand 20/20 vision and non-colourblind people, yes.
Question. One, does that mean I can't drive to have 20/20 vision?
No, I said if you're colourblind you can drive, there's no problems there.
And
But
also,
you won't be able to become a professional airline pilot. And even that may have changed.
how are colourblind glasses made?
They just blot out, they absorb wavelengths that you would normally see. So they might blot out the red that would normally come in, so you won't detect them. Now, colour blindness, yeah, fine. Here is a black and white picture. Geez, that's insufferably difficult on the projector. It's difficult on the computer. Okay, so why would colour vision have evolved? Well, if you're a dog walking around the jungle, that's how you see the jungle. Now, if you're me walking around the jungle, hopefully you can see that panther and avoid it. Okay, same photo, exactly the same photo, but colour vision gives you the ability to get a bit more information out of the world. Like, oh, there's maybe some food that I can eat, some fruits or something that I detect purely because they're a different colour to other things. Or maybe I can avoid being eaten by something because I'm able to detect them. Okay, yes?
A dog's colourblind.
Yes. Not as colourblind as we used to think. I'll show you after this. I've just remembered a really cool video of a tiger moving through high grass. Now, tigers are black stripes and pretty vivid orange. And you're thinking, not the best thing in the world if you're moving through dry grass. You will not see this tiger. Okay, it's strange, but they know what they're doing. Okay, now, here is eye vision problems and how they're corrected. Nearsightedness or myopia, think NM, close to each other on the alphabet, from images being focused in front of the retina. So instead of the image being projected here, it's being projected here, and those light rays keep going, so they actually continue back to the retina, and so not everything is being focused on the retina properly, so you get that blurred vision if you're nearsighted. Objects appear blurred, corrected using concave or a diverging lens. By diverging the lens, the light goes that way, it hits the lens of the eye at a different angle, and you end up getting focus on the retina in the way that you wanted. The opposite of that is true. Far-sightedness, the opposite of nearsighted, eyes focus images slightly behind the retina, and nearby objects appear blurry. So again, we've got this situation here, and this can be happening because of a genetic condition. It could be happening because your eyes are getting older, and they're not as flexible as they used to be. And that is corrected again by using a lens which changes the path that the light takes into the lens of the eye, and you get the focus onto the eye. Yes?
Would you be blind if you had nearsighted and farsighted?
No, you're just going to have, you're still taking light signals in. And I don't know how you can have both nearsighted and farsightedness because they're, it's the same lens. If you're going one eye is one and one eye is the other. So you're going to be blurry in different ways. And to be honest, anyone who has glasses, you probably don't have the same script in each eye. They test both eyes individually and they go, oh yeah, this one's a little out this way, this one's a little out and that way. And they try and get those glasses to work. Now, there we go. Binocular vision. Very handy for seeing things, you know, in terms of judging distances accurately. And that's why predators tend to have binocular vision. Their eyes on the front and allows them to focus. Birds are a little bit different. They tend to, eagles though, mind you, do have pretty much eyes on the front, whereas a lot of other birds will have them towards the outside, and they will tend to be, so that they have better vision behind them, so that they can avoid predators. But birds of prey, think about owls, they have almost a flat face and their eyes again on the front to give them that good judgment of distance. Yes?
Wait, what's the tiger?
Yes, I'll get to that. Okay.
Mr. Maz, can't owls just turn their head like all the way around anyway?
Yes, but that's not what they're doing. This is for distance vision.
Don't
Yeah,
owls
yeah,
have the best
done.
vision?
Five
Or some